This is a very quick version of the evolution of the atomic model. It has been simplified to present a basic idea of how the model has been changed by scientific process and thought in the last 200 years. We are still modifying this model today. We begin with Democritus, a Greek philosopher who lived almost 2,500 years ago. Democritus did a thought experiment involving a sharp knife and a piece of chalk. He believed if he cut the chalk in half, and then took that half and cut it in half again, and cut it in half again, eventually he would come to a piece of chalk that was uncuttable. This indivisible particle, he thought, was the basis for all matter, and he called it, for the Greek word indivisible, which was atomos. Almost 2,000 years later, in 1800, an English school teacher named John Dalton said the same thing as Democritus. Why did it take so long for Democritus' thoughts to be published in the scientific community at the time? One word, Aristotle. Another Greek philosopher who had an earth, air, water, fire model that because of his strong influence basically was the scientific knowledge for almost 2,000 years. Dalton revived Democritus' ideas and said matter is composed of indivisible particles. He visualized these particles as small, hard, dense spheres similar to billiard balls. Dalton stated that all the atoms of an element were identical. For example, in a sample of oxygen, all of the atoms in there would be the same small, dense, hard spheres. We know now that this is not completely true. You learned this when you studied about isotopes. Dalton was correct when he said that different elements are composed of different atoms. We take a more technical view of this now, and we think that actually it's the number of protons that determines which element is present. Different number of protons means a different atom. Finally, Dalton was quite intuitive about how elements combine in chemical reactions. He said that atoms combine in certain whole number ratios. We know this to be the case even today. A good example would be water, which always combines in the ratio of 2 hydrogen atoms to 1 oxygen atom. If we fast forward about 90 years to the late 1800s, a physicist named J.J. Thomson, experimenting with cathode ray tubes, discovered a very small negative particle that he called the electron. This forced scientists all over the world to start to think about how to modify Dalton's model for matter to include these negative particles. A new model was proposed that is often called the plum pudding model. This model includes the negative electrons and an equivalent amount of positive charge because the atom overall is neutral, but the positive charge was of some strange undefined composition. Because this model resembles raisins, the electrons, stuffed into a plum pudding, the positive charge, it is called the plum pudding model. Ernest Rutherford was not happy with this model, so he had his students do an experiment to test it. Hans Geiger and Ernst Marsden performed an experiment called the gold foil experiment, in which they bombarded a very, very thin piece of gold foil with alpha particles. The results of the gold foil experiment showed that the thin gold foil, or the gold atoms, actually deflected some of the alpha particles, which was against what they thought the plum pudding model would predict. This led Rutherford to come up with 2 new ideas or postulates to the atomic model. Number 1, at the center of an atom is a small, dense, positive nucleus. And number 2, aside from the nucleus and the electrons, the atom was mostly empty space. A Danish physicist named Niels Bohr theorized about the nature of the electrons and how they actually surrounded the nucleus. Bohr looked at hydrogen spectrum data as evidence to propose that the electrons circle the nucleus in discrete energy levels called orbitals. Here's where we finish the basic understanding of atomic structure, and this is sort of the limit of the course that you're taking in school today. We can go further to more advanced atomic structure and talk about wave models of atoms and how the atom is an indiscriminate cloud, but that's beyond the scope of this story.